This newly discovered comet could soon glow bright enough for the naked eye as it sweeps through October's morning and evening skies. Comet Lemmon, C 2025 A6, is quickly brightening as it draws closer to both the Sun and Earth, evolving into a striking object already visible through small telescopes and binoculars, and soon, quite possibly, to the naked eye. The icy visitor, discovered on John 3 by the Mount Lemmon Survey in Arizona, is the brightest comet to appear in our sky since Comet C 2024 G3 Atlas last January. It will swing close to the Sun, a point called perihelion on November 8, passing about 49.25 million miles, 79.25 million kilometers, from our star. Now, as it brightens rapidly in the pre-dawn sky, sky watchers around the world are preparing for its best and possibly brightest display in late October. Typically, during a given year, several comets will appear that come within range of good binoculars or small telescopes. But a comet bright enough to be readily visible to the unaided eye comes along usually only once or twice per decade. According to the most optimistic forecasts, at its brightest later this month, Comet Lemmon is projected to possibly approach +3 magnitude. Such a brightness is comparable to the star Megrez, the star in the Big Dipper that joins the handle with the bowl. So these upcoming weeks will afford sky watchers an unusual opportunity. Of course, a comet's appearance is much different and less well-defined than the sharp image provided by a star. In August 1974, Kenneth Weaver, an assistant editor of National Geographic magazine, provided an excellent description of a comet somewhat comparable to Lemmon. He had traveled to the dark skies of Kitt Peak National Observatory near Tucson, Arizona, for a glimpse of Comet Kohoutek. He wrote, "No spectacular lighting of the sky, no radiant display. One moment it was not there, the next moment it appeared. To the naked eye, it seemed as though a giant paintbrush, dipped in whitewash, had been drawn swiftly across the black wall of heaven, leaving a ghostly swath above a gently glowing blob." But when Mr. Weaver wrote these words more than half a century ago, he was describing a modestly bright comet from a location completely free of light pollution. Today, with the glare of bright light seemingly metastasizing everywhere, it is far more difficult to find such dark, starry, and pristine conditions. Urban sky glow has robbed many of us of our night skies, and the vast majority of the population of the United States now lives in regions where the stars are mostly blotted out by excessive lighting. If you live in a bright city or suburban area, your best chance to see Comet Lemmon will be to head to a dark sky site far from streetlights. Look for a place where the Milky Way is visible overhead, a sign of truly dark conditions. Under hazy, light-polluted skies, the comet may appear faint or not at all. Comet Lemmon has proven to be a particularly active comet, with noticeable changes occurring almost from night to night. As it races toward the inner solar system, the comet will continue to brighten through October while gradually expanding in size. Its closest approach to Earth, perigee, comes on Oct. 21, when it will pass about 55.4 million miles, 89.2 million kilometers, from our planet. Predicting what a comet will look like, however, is notoriously tricky. Its brightness, color, and tail shape depend on several factors: its orbit, its angle relative to Earth and the Sun, and the makeup of its icy nucleus. Each comet's heart is a clump of ancient solar system debris, a mix of dust, rock, and frozen gases, much like the particles that make up Saturn's rings. As sunlight heats that nucleus, the ice vaporizes, releasing jets of gas and dust that form the comet's signature tail. In Comet Lemmon's case, early images show that its tail is made mostly of gas, giving it a faint bluish hue and a thin, straight appearance pointing directly away from the Sun. On the other hand, comets that are prodigious producers of dust are the ones that are eye-catching because such dust tails appear much brighter. The dust tail is a flat sheet of material spread out in the plane of the comet's orbit, with one edge immediately adjacent to the gas tail. To date, most of the reviews coming in concerning the comet's appearance have been very favorable. Despite bright moonlight from October's full supermoon, recent comet brightness estimates at the Comet Observation Database indicate that Lemmon has been a relatively easy object to sight with good binoculars. As of October 6, a consensus of the comet's brightness showed it hovering near magnitude +6.1. The lower the figure of magnitude, the brighter the object. The brightest stars are magnitude 0 and +1. The threshold of naked eye visibility under a dark, moonless sky registers at around +6. The head or coma measures at around 8 minutes of arc, or roughly 1/4 the apparent size of the moon. Visually, the length of the tail is around 1 degree or twice the width of the moon. Long exposure photographs, however, show the faint gas tail to be many times longer. Currently, Comet Lemmon is a morning object. In order to see it, you'll have to get up before dawn breaks, about 90 minutes before sunrise. The comet is currently passing through the southern boundaries of Ursa Major, the Great Bear. This comet is developing very nicely, and it is already an impressive object, well placed for observation in the morning sky. Nick James, director of the Comet section of the British Astronomical Association, told spaceweather.com, "It is definitely worth getting up for." The full moon, on Oct. 6 made spotting faint objects difficult, but visibility will improve as the moon wanes. After last quarter on October 13, the moon becomes a slim crescent, allowing much darker skies for comet viewing. Thursday morning, October 16, will provide a great opportunity to locate Comet Lemmon thanks to its proximity to a conspicuous star. That star is Cor Caroli, the brightest star in the constellation of Canis Venatici, the hunting dogs. Cor Caroli shines at magnitude +2.8, and on October 16, the comet will be situated just 1 degree, 2 moon widths above that star. 90 minutes before sunrise, look for the Big Dipper, which will appear to be standing upright on its handle in the northeast sky. Now draw an imaginary line diagonally through the Dipper's bowl from Dubhe, the upper right star in the bowl, down through Phecda, the lower left star in the bowl, and extend that line downward about twice the distance between those two stars, and that will bring you to the vicinity of Cor Caroli. Aim your binoculars toward this star, and Comet Lemmon will be situated just above. October 16 is also the date when the comet will become available to evening sky watchers. In fact, Lemmon will likely put on its best show between October 22 and October 28, low in the west-northwest sky, right after the end of evening twilight. During that time frame, the comet will be tracking rapidly through the constellation Boötes the Herdsman and into Serpens the Serpent on Oct. 24. Around the end of twilight, it will sit about 15 degrees above the horizon, roughly 1.5 fist widths at arm's length. On the evening of October 22, the comet will lie about 2 degrees left of the star Isar, Pulcherima, a beautiful double star with a yellow and blue color contrast often described as golden and sea green. Oct 22 through Oct 28 will also be when the moon will not be much of a factor, being no worse than a waxing crescent phase. This will also be the time when Comet Lemmon is expected to shine at its brightest. Japanese comet expert Seiichi Yoshida thinks the comet will peak at around +4 magnitude, but Dutch comet expert Gideon van Buitenen has recently revised his brightness forecast, indicating that the comet might get as bright as magnitude +3.3, which would make it evident with the naked eye against a dark sky. I think we can now be reasonably confident that this will be a very nice evening object when it is at its brightest around new moon in late October, adds James. Those blessed with very dark skies might even be able to continue following with just their unaided eyes until the first week of November. Of course, the comet could always dim much more rapidly, or a sudden unexpected flare-up could also occur. But these are extreme cases. So far, the comet has performed very well, and there is no reason not to believe that it will continue to delight Northern Hemisphere observers for a few more weeks. Once again, we should stress that the darker your observing site, the better the comet will appear. With the bright moon pretty much out of the way during the 2nd and 3rd weeks of April, prospective comet observers are likely to have their greatest success. Good luck and clear skies. On September 10, Vladimir Bezugli of Dnipro, Ukraine was examining online images of a low-resolution public website showing images obtained during September 5-9 with the Solar Wind Anisotropies SWAN camera on the Solar and Heliospheric Observer SOHO spacecraft. That's when he discovered a moving object resembling a bright blob close the sun. The blob turned out to be a comet, a bright comet. In fact, as Bezugli later noted, "In my memory, this is one of the brightest comet discoveries ever made on SWAN imagery," adding, "the 20th official SWAN comet so far." Since Bezugli's first sighting, many other amateurs, primarily in the southern hemisphere, have viewed it. The comet has since received a formal IAU designation on September 15 as Comet C 2025 R2 SWAN. Astronomers rely on magnitude to determine brightness. Magnitude is a numerical scale used in astronomy to measure the apparent brightness of celestial objects, where lower numbers indicate brighter objects and higher numbers indicate dimmer objects. The brightest stars are magnitude 0 or +1, while the limit for naked eye visibility under a dark, non-polluted sky is considered to be magnitude +6.5. A consensus of the most recent observations of Comet SWAN indicated a magnitude of +7, which places it just out of the reach of naked eye visibility under dark, moonless skies. Good binoculars, however, can readily bring it into view. The typical description of the comet by those using binoculars and small telescopes is a small condensed head or coma, with a thin, faint tail extending for roughly 2 degrees. An orbit based on 60 different observed positions between September 12 and 14, 2025, has been calculated by Shuichi Nakano of the Central Bureau for Astronomical Telegrams. He finds that the comet passed perihelion, its closest point to the Sun, on September 12 at a distance of 46.74 million miles, 7520 million km. While it is now moving away from the Sun, it is currently approaching Earth. It will come closest to us, perigee, on Oct 21 when it will be 2510 million miles, 4038 million kilometers away. Based on its orbital eccentricity of 0.996015, the time it takes for Comet SWAN to make one complete circuit around the Sun is estimated to be on the order of roughly 1,400 years. A number of different predictions have been made regarding the brightness Comet SWAN as it passes closest to Earth during the 3rd week of October. To date, brightness forecasts issued by Japanese comet expert Seiichi Yoshida and Dutch comet expert Gideon van Buitenen indicate that the comet will peak somewhere between magnitude +6 and +7, probably placing it right on the cusp of naked eye visibility, but certainly within reach of good binoculars or small telescopes. Daniel W. E. Green at the Central Bureau for Astronomical Telegrams suggests that Comet SWAN will hover near magnitude of +6 from Octi to 2 to 20, perhaps becoming a few tenths of a magnitude brighter for a few days around Oct 12, meaning it might become faintly visible with the unaided eye. Right now, as we noted earlier, Comet SWAN has been primarily visible from the southern hemisphere. It's been too close to the Sun to be easily visible north of the equator. But that will gradually change by the end of this month, as the comet takes a more northerly path. It will slowly climb higher in the southwest sky during the first 10 days of October, reaching an altitude of 12 degrees above the horizon at the end of evening twilight, approximately 90 minutes after sunset. Your clenched fist is equal to roughly 10 degrees when held at arm's length. By October 28, the comet's altitude will have climbed to 30 degrees, 3 fists, above the south-southwest horizon by nightfall, and by Oct 25, it will stand halfway up in the southern sky when twilight ends, and not set until after midnight. During October, Comet SWAN will move along a path taking it across the constellations of Libra, Scorpius, Ophiuchus, Serpens, Scutum, Sagittarius, Aquila, and Aquarius. As is the case with another comet we have recently discussed, Comet Lemmon. Sighting Comet SWAN may prove to be rather difficult for locations that are plagued by light pollution. Remember, you're not looking for a sharp star-like object, but rather something which is spreading its light out over a comparatively large area. Like Comet Lemmon, Comet SWAN does not appear to be a dusty comet, but is primarily composed of gas. Such comets appear fainter than comets composed primarily of dust, which is a far better reflector of sunlight, and glow with a bluish-white hue. The gas is activated by the ultraviolet rays of the sun, making the comet glow in much the same way that black light causes phosphorescent paint to light up. So, most who ultimately locate Comet SWAN in their binoculars or telescopes will likely describe it as a nearly circular cloud, appearing noticeably brighter and more condensed near the center. Some might also detect its faint tail appearing as a bit of a thin, narrow appendage, extending out from the comet's coma, sort of like an apple on a stick, but hardly the kind of tail exhibited by other larger and brighter comets. One other attribute that has been widely promoted on social media about Comet SWAN is the possibility that it might cause a meteor shower sometime between October 4th to 6th. The reason that this potential has been suggested is that in diagrams showing the comet's orbit, relative to the orbits of the inner planets, it appears that Comet SWAN's orbit intersects the orbit of the Earth right around Oct. 5. The assumption is that if there is any meteoric material that has been shed by the comet on previous trips around the Sun, that there is a chance that the Earth will encounter it around the time it intersects the orbit of the comet. An intriguing theory, but it is not likely to happen. The reason is that the orbits of Earth and Comet SWAN will not intersect on Oct 5. What is transpiring is that both objects are traveling on curtate orbits. When looking at the orbital paths from a perspective high above, it certainly appears that the orbits interact with each other, but in reality, according to my calculations, at the octular 5 point of our orbit, the comet orbit, and any possible cosmic debris that is traveling along it, will travel far above our orbit and will miss us by some 4.4 million miles, 7 million kilometers. That is far too wide a gap between the two orbits to hope for any type of semblance of significant meteor activity. Besides, the best chance to encounter any meteoroids shed by Comet SWAN would be behind it, but Earth arrives at the Oct 5 point, ahead of it, 16 days before the comet itself passes by. And we've already noted that Comet SWAN is mostly a gaseous comet, and not a dusty comet, so it is not likely shedding very much material along its path around the Sun. Thus, even if we were to encounter the comet orbit directly, there seems little chance we'd encounter very much comet debris to produce many celestial streaks.